Hello, welcome to Security. This is Cesar, and this is the fourth and final part of the AWS WordPress 3T Architecture Project series. So far we've set up the bulk of the architecture in the previous parts, which I'm going to link to this video. And in this video, we're going to set up basically the remaining part. We're going to set up the application load balancer, set up the remaining parts of the settings in the WordPress instance, also create an AMI for the auto scaling and set up auto scaling as well, and also set up NAT gateway with remaining settings in the VPC. So yeah, let's just get right into it without further ado. So from where we stopped in the last video, after testing the CloudFront setup, I'm going to set up a page on the website that I'm going to be using to test the server, check the server IP. And this is going to come in handy after setting up auto scaling. So I'll create this file, check server ip.php, and paste in this code. And this PHP code, all it does is when I visit that page on the web server, on the server, it's going to return the internal IP address of the server, as you can see here. Okay. So with that, I'm done with the settings for the WordPress instance, which I'm going to use to create my master AMI for the setup for auto scaling. So I'll return to the EC2 console now and create an AMI of this instance. So with the server selected, I'll just click on Actions, Images and Templates, and create an image. And then I'll give the image a name. And I just click on Create Image. Okay, so now if I check AMIs, I should see the image being created, and it's in the pending state. So I'll just pause the video for a couple minutes and come back when it's done creating. Okay, so now the image is ready. What I'll do now is go back to the VPC console and complete the setup. If you remember, during the initial VPC setup, I set up the subnets, but I did not set up the route tables for all the subnets. I only set up the route table for private subnets app1, and I temporarily connected it to the internet gateway for the initial setup. So now I'm going to set up all the route tables for all the subnets, how they're supposed to be. So the first thing I'll do is create a NAT gateway, and the NAT gateway is going to be the source of internet access for resources in the private subnet. So I just give it a name, put it in the public subnet, I allocate an elastic IP, and create the NAT gateway. So resources in the public subnet reach the internet through the internet gateway, and resources in private subnet can reach the internet through a NAT gateway. The difference is with an internet gateway, they can reach the internet and they are also reachable from the internet. With a NAT gateway, they can reach the internet, but they are not reachable from the internet. So I'll create. Next, I'll go edit the route tables. I'll start with the private app1 route table, and I'm going to remove the route that I put in earlier, connecting it to the internet gateway, and then connect it to the NAT gateway instead. So I'll delete the route and add the route to the NAT gateway that I just created. So I'll save the changes. And next, I'll put in the route for the remaining route tables. So I go back to the route tables and select the next private route table and connect it as well to the NAT gateway. Save. Go back to the route tables. Select the next one, the private app2 route table. Same thing, edit the route and connect it to the NAT gateway. And finally, I'll do the private data2 route table and do the same thing, connect it to the NAT gateway. Okay, so I believe that's all we need to do in the VPC console. Of course, the public route tables are already connected to the internet gateway, so we don't need to do anything there. So I just confirmed that I can still connect to the WordPress instance through the Bastion host. And yes, I can still connect. However, because the instance is no longer reachable from the internet, the website will be unavailable. Okay, so back to our reference diagram. We have set up everything with regards to EFS, Elasticache, the database, and we've also set up the master instance image, which we're going to use to set up auto-scaling, and also set up all the public subnets and private subnets with the route tables. So yeah, so next we're going to go into auto-scaling. But yeah, and of course we also set up S3 and CloudFront. Okay, so now we'll go back to the EC2 console. Before we create the auto-scaling group, we have to first of all create the security group for the load balancer. So I'll go to the security group console and create a security group. I'm just going to give it a name, give it a description as well. I'll connect it to the WordPress project VPC, and I'm going to add rules for HTTP and HTTPS from anywhere, inbound rules. And I'll create the security group. Also, we're going to edit the WordPress app security group, and we're going to remove the rules that allows traffic from anywhere, and we're going to allow the traffic from only the load balancer. So we'll delete the previous rules and now allow HTTP and HTTPS only from the load balancer security group instead of from anywhere. Of course, we still want SSH traffic only from the Bastion host security group, so we don't change that one. Okay, so that's done. So now we can go to the auto-scaling groups and create an auto-scaling group. So I'll give it the auto-scaling group a name. And I'll have to create a launch template. So I'll just click on create launch template, which will open a new tab. I'll give my launch template a name. I can also give it a description. For AMI, I'm going to click on my AMIs and select the one I just created. And for instance type, I'll select the T2 micro, which is feature eligible. For key pair, I'll just select any one key pair I already created. I'll just leave network settings blank for now. And for advanced details, I'll select the instance profile I created to give the EC2 instances access to S3. I can also go ahead and select the WordPress app security group for the instances. I'll just leave the rest of the settings as default, and I'll create the launch template. Okay, so now I can return to the auto-scaling group console. I'll refresh the launch templates and select the one I just created. I'll click on next. For the VPC, I'll select the WordPress project VPC. And for the availability zones and subnets where I want instances to be launched, I'm going to select the private app 1 and private app 2 subnets. So I'll click on next. For load balancing, I'll select attach to a new load balancer, an application load balancer, and I'll give it a name. And I want it to be internet facing, so it's reachable from the internet. So for the availability zones and subnets, I'm going to select both public subnets. I'll also create a target group and give it a name. I'll leave this as default. I'll also leave the rest of the settings as default and just click on next. So for desired capacity, I'm going to say 2. So there should always be 2 instances running. I'm also gonna set the minimum as 2 and the maximum as 4. I'll also set up a target tracking scaling policy such that whenever the average CPU utilization is 50% or above 50%, then a new instance will be launched. So I'll click on next, next, and just review and create the auto-scaling group. So once it's created, you're gonna see it's gonna start updating capacity immediately. And if you open up the auto-scaling group and click on the activity tab, you're going to see it is launched in 2 new instances. If you go to the instances in the EC2 console and you refresh, you're going to see 2 new instances have been launched. Oh yeah, I did not set up a tag, but you could set up a tag as well in the auto-scaling group, so it gives names to the instances that it creates. But you can see 2 instances are already in dependent state. So for now, I'm just going to stop the initial WordPress instance that I created because we really don't need it right now. So I'll just put it in the stop state so it's not incurring more charges. So if I go back to the auto-scaling groups and check the activity, you can see it says successful. So we also have a target group and load balancer created, and we can check that as well. So you can see it's provisioning a load balancer, and the target group has also been created. So when the instances are done being created, they're going to be added to the target group, and the load balancer is going to forward traffic to healthy instances in the target group. So yeah, so now we just have to give it all some time to finish provisioning and to be available. So I'm just going to pause the video and come back when it's done. Okay, so after a few minutes, you can see the load balancer is active. And if we go open up the target groups, oh, it says our instances are unhealthy. So I'm going to have to troubleshoot that, but first of all, I'm going to change the Route 53 settings to point to the load balancer instead of the elastic IP address. So you can copy the DNS name from the load balancer console, or if you're also using Route 53 for your DNS management, you can select the record and edit, and select an alias type, turn on the alias type. You choose an application load balancer, application and classic load balancer, and you select the region where it is running. Mine is the US East 1, not Virginia. And I'm going to select the load balancer and save. So this option is available if you're using Route 53 to point to AWS resources. So the site is unreachable for now, and that's likely because the instances are seen in the unhealthy state in the target group. So I'm going to troubleshoot that now. So I'm just going to first of all connect to the instances and confirm that all the files are that the web server is running on the instances and all the files are present. So I'll copy the private IP and connect from my Bastion host. Okay, so I'm into one of the instances. I can check the Apache 2 status, and I can see that it's running. I'll also check that the WordPress files are present, and you can see that they are present. I can see that the cron job I created is also there, and here the EFS file system is also mounted on the folder as I set it up. So it doesn't seem that there is any issue with the instance. So I'll just continue some troubleshooting. So I did some research and found that what might be causing the issue is the path for the health checks, and I need to specify a path where I have configured the web server to return a response. So I'm gonna check that. But I also found that it could be a security group issue, so I'll check that first. So back in the EC2 console, I'll check the security group for the um, instances. And I'm just gonna check that the rules are correct. And yeah, there doesn't seem to be anything wrong with the security group for the instances. So I'll also check the security group for the load balancer as well. So, oh yeah, so I see the load balancer is connected to the WordPress app security group, and it shouldn't be so. It should be connected to the load balancer security group. So I'm gonna edit that. I'll remove this security group and connect it to the ALB security group. Now save changes. So next I'll go back and check the status of the instances in the target group. Okay, so the instances are still unhealthy. So next I'm going to change the health check settings. So I'll click on the health check tab, and I'm gonna just put the path to the check server IP.php file that I created, because I know that's gonna give a response. So if this is reachable, then this server should be marked as healthy. So I'll give it a couple seconds and check the status again. And yeah, voila, we can see our instances are healthy now. To confirm, we should be able to reach the website now. So just try and visit the website, and yes, the website is reachable now. So another reason for the check server IP was to show how load balancers work on AWS. So we can see that every time I run the check server IP, it's redirecting me to a different instance. And these are the instances that have been created by the auto-scaling group. Yeah, we can confirm that by going to the EC2 console. If I select the first instance and check the details, you can see the IP address. And if I check the second instance, you can see the IP address as well. And those are the IP addresses we've seen when we visit the check server IP site. So we can also check the behavior of autoscaling when we terminate one of the instances. So first of all, I'll just open up the activity tab of the autoscaling group, so we can see how quickly it's going to pick up change to the configuration. So I'm going to terminate one of the instances. And if I go back to the autoscaling group console, you can see the instances shutting down. I think it takes like a minute. It's not so much instant, but in a short time we should see that it's picked up that one of the instances have been terminated. So I'll give it a couple seconds. Okay, so after a minute or two, we can see it's picked up that one instance has been terminated, and it has launched another instance to replace the instance that was terminated. So right now, if we go back to the target group, load balancer target group, you see it's only one instance that's held here right now. Okay, I think I took too long to come back because the instance is already available. I was going to show the behavior of the load balancer when only one instance is available. So I think what I'm going to do is I'm going to kill terminate another instance to show that. Okay, so I'll just go back to the EC2 console and terminate um, the other instance. Yeah, it takes a while for the auto-scaling group to find the instance it's unavailable. Anyways, so if I try to visit the site now, you can see it's redirecting me to just one instance because only one instance is available. Okay, so after a few minutes, we can return to the auto-scaling group console, and if we refresh, we can see it has picked up the terminated instance and launched a new one. Okay, so it takes some time for the instance to boot up. Right now, we still have one instance held in the target group. And if we go check the website, we're still able to reach just one instance. So I'll give it a few minutes and come back. So after a couple minutes, you can see both instances are now in the healthy state. And now from the website, we are being redirected to the two instances. Okay, we can also just confirm that both instances are reachable from the Bastion host via SSH, and confirm also that all the files are available on both instances. So this is the first instance. I've connected by SSH, and I'm just going to check for the WordPress files. They're present. So I exit. I just clear the terminal and also check the second instance. So I refresh the page, get the second the IP of the second instance, and also I can connect to it over SSH. Also, I can check the files, and they're also present. Finally, I will go back to the WordPress dashboard to confirm that I can still add posts successfully, and that the settings for static files is still working as intended. So I'll go to the home page and visit the dashboard, and I'm just gonna add a post, add a new post. And I'll call this one test after auto-scaling. So I also add an image and publish. Okay, so next I'll view the post and open the image in a new tab. Okay, I'm getting an access denied error, and this happens sometimes. All you have to do is go back to the page, refresh the page, and then you can open up the image again. And you can see the image is still being served over CloudFront, so which means it's working properly. Okay, so I think with that we are at the end of the project. We have set up everything in this architecture, from Route 53 to CloudFront to the S3 to the Internet Gateway, the NAT gateways, the Bastion host, the load balancer, the auto-scaling groups with the instances in different availability zones and different subnets, as well as the data resources as well, like the EFS file system, the RDS database, and Elastic Cache as well. So yeah, I believe the only thing I didn't set up was I didn't set up a NAT gateway in another availability zone, because this is just a demo and I didn't want to incur much charges. And also, I didn't set up CloudFront behind Route 53. such that when I open up the static image files that's saved over CloudFront, instead of showing the CloudFront URL, it shows my domain. Yeah, I actually just forgot to do that until it was too late. And yeah, if you want me to post a video showing how to do that, leave a comment and I'll do that. Okay, so with that, we're done with the project. And yeah, one important thing not to forget is to terminate all your resources, not to incur additional cost. And I'm just gonna show you how to do that quickly. First of all, you need to terminate the auto-scaling group, because this will automatically terminate the instances, the load balancer, and also all the resources that the auto-scaling group created. So I'll just delete that, and it will take some time to terminate all the instances and all the resources. Also terminate the bastion host as well as the initial WordPress instance. And just terminate those instances. The auto-scaling group is still terminating the resources. So next, I'll go to the CloudFront console and first of all disable the distribution. And once it's done disabling, then I'll delete it. Next, I'll go to the RDS console and delete the database. I don't need a snapshot, acknowledge, and type in delete me. And just give it some time to be deleted. Same thing for Redis. I'll go to Redis and delete the cluster. I don't need backups. Type in the name and delete. Also, I can delete the EFS file system as well. Okay, so just check, and the auto-scaling group is still being deleted. Okay, the instances have been terminated now. I'm just gonna check. Okay, so the auto-scaling group has successfully deleted all resources. So next, I'll delete the S3 bucket, but to delete that, I first need to delete all the files in the bucket, and I'll delete the files in the bucket first. And then I can go back to my buckets and delete the S3 bucket that I created as well. Next, CloudFront should have disabled the distribution now, and I can go and delete it. And the database is still being deleted. Redis as well is still being deleted. So finally, we can go to the VPC console and delete the NAT gateway and also all allocated elastic IPs. So yeah, so if we delete the NAT gateway and next go to elastic IPs and delete the allocated elastic IPs. This one is linked to the NAT gateway, so you have to wait for the NAT gateway to be deleted first before you can delete it. Okay, so yeah, make sure to delete all the resources that could incur charges, so you don't incur extra charges when you're done with the project. And yeah, if you've watched to this point of the project, thanks for watching. If you have any questions or suggestions, or you're unclear on anything in the project, you can leave your comments in the comment section and I'll get to them. If you're enjoying the videos or they're helpful to you, please like and subscribe to support the channel. And yeah, thanks for watching, and I'll see you in the next video.